Hey guys, welcome to the Joe Jaguar show again. And I totally messed up. And so this video is going to be a repeat video. So if you're wondering what happened, this is what happened. Okay, so I just released this video just 4 or 5 weeks ago, and it was going pretty good, but I had an unlisted video and I didn't want it, so I went on to where you can delete them, and the video that I wanted to delete was right under this video, which is called Misconceptions of Equatorial Mounted Telescopes. And then I hit this one, and then I confirmed, and then as soon as I noticed when I confirmed, oh damn, it's the wrong video, it's the one underneath I wanted to, there's no stopping it. I try to close it, and once you hit that accept or confirm button, it's gone. So I lost that video, so I'm gonna redo it again. So for you guys that seen the video and don't mind watching it again, or for you guys that made a comment and don't mind making a comment again, I guess I'm gonna start from 0 views again, but at least I can remake it. It wasn't that hard of a video, but I think the information is gonna help people out. So let's do that video again, called Misconceptions of a Equatorial Mounted Telescope. Okay guys, so here I have an equatorial mounted telescope and tripod. This is a Orion, not that it matters anyway. This is a 130 millimeter f5 or 5.1 inch reflector. Anyway, it doesn't matter. The smaller reflectors, larger reflectors. This is an EQ2. It doesn't matter if it's in EQ1, 3, 4, 5, or whatever it is. So, okay, the first thing that you should know, let me get you closer, is your latitude, okay? You should know where you're on Earth. I mean, that should be basic knowledge. If not, just Google it. But I guess you don't need to know that for Dobsonians and Altazimuth type, but for an equatorial, you just need to know what latitude you're on. Okay, every equatorial mount is gonna have one of these. It's a latitude adjustment between 0 and 90, and basically I'm at 43. So you just set that for whatever latitude you're on and then lock it down. If it has a locking nut, it should. And then that's it. That's the only thing you need to do that. Even if you go 3, 4, 5 hours away, you really don't need to change it. These things are not 100% accurate. Every tick is like 2. So just get it as close as you can. Okay, so polar alignment does not have to be that hard. It could be as easy as literally you're gonna see just a few seconds. Now I just read this just like less than an hour ago. Someone on one of the forums said equatorial mounts is mainly for imaging. That's incorrect. It can be for imaging, but it can also be for visual, where you just want good tracking. Okay, so as long as you have your latitude adjustment, and then you know north, south, west, east, okay? My townhouse is on the north side, so I get no 180 view on the north, so I cannot see the Big Dipper or Polaris at all. Okay, so for simple, just observing, simple polar alignment, you just point it north. If you know north, south, west, east, as long as you know that, that's it. Just point it north, and then you would just unlock the nuts. If you want to face that way, look this way, up that way, or in the other direction, like that or that. And that's really it. That's it. Now, so that's all you really have to do. It literally took me 2 seconds to point it north, and then now you have decent tracking. Now, just by pointing it north and your latitude there, so basically what it is the closer you are, this mount, this axis here, hole here where you put an eyepiece, and the closer you get this axis to the North Star, true north, the more better tracking it's going to have. So I know that the Polaris is not exactly, this is like kind of magnetic north, and true north is just about 15 degrees that way. That's even closer to north, but really I'm kind of still guessing. And even if you watch my videos, you'll see that's all I really do. Just instead of pointing it like a straight line north and south. If you know your offset from magnetic north to true north, you can use a compass. You can use your smart app on your phone will probably give you a compass, and it'll kind of show you where the offset is. Just point it in that direction. Now you have even better tracking. Meaning, if you're 100% polar aligned, like the kind that has the eyepiece, and you have a dead center, you could be hours. And then all you have to do is manually use one motion control instead of two all the time. And then a little bit, if you're further off from Polaris, then you probably have to touch the second control once every like 15 minutes. And if you're a little bit off more, once every 5 minutes. And if you're off more, once every 2 minutes, that type of thing. So that's all it is that the more accurate you put your mount closer to the true north or Polaris, the North Star, whatever term you use, the better tracking you're going to do. Now, if you don't even know that, you can just point north and you're going to have decent tracking where you're only controlling one axis, and then the second axis you're just periodically doing. That is it. Okay, the second misconception of equatorial mounted telescopes is this. Now, people say when you're viewing, let's say in that angle. Now, as you can see, let me lock it down. The focuser is all the way down here. So the focuser is all down here. They say there's these weird angles. All you really have to do is loosen the rings. Almost every telescope now comes with this type of setup. Loosen the rings and then just twist and then tighten down. So that doesn't matter whatever angle you're on. If it was in that direction or up, you just twist the rings, put it to a more comfortable situation, and then that's it. So it's really not hard at all. Now, I have heard people say, okay, but if you have a go-to mount, that could screw it up. I don't think so. And because you're only twisting the tube. Now, if you move the mount, I think then you would change it won't be aligned anymore. But in this case, I don't think, 99%, if you're just twisting it, you're not going to be moving, the telescope at all. So it should be fine, I think. So there's the second. Now, let me take you inside for how the tracking might be beneficial to you by using that. Oh, and by the way, there's another YouTuber that I watch, his channel, he watches mine. He's roughly at about the same subscribers as me. He's also been interested in a long time. He actually gave me a great compliment, and it's great to hear sometimes. Now, he said in his 30 years of experience, he almost always uses Dobsonian telescopes, which is great, which is fine, no problem there. But after watching this video I did about 4 or 5 weeks ago, he said he gave it a try, and he kind of likes it. It's, for tracking, he found it okay. So he gave me a compliment there, so I appreciate it. So basically I'm telling you guys to do the same. Just point it north. It literally takes 2 seconds. If you have a bigger, heavier mount, okay, it might take 10 seconds to lift it and turn it. No big deal. But the more you have it polar aligned, the better tracking it gets. That's all it is, and the less maneuvering you do. Now, I just had a star party, and I brought a 10-inch Meade Lightbridge Dobsonian to the star party that I hosted for the people that are subscribed to me in this area. And we were looking at Saturn, and I took it to, I believe it was an 8.8 millimeter Meade ultra wide. That's the 84-degree field of view. The ones made like 20 years ago in Japan, which are amazing eyepieces. Anyway, and I believe that's about 142 power, and I didn't dare push it anymore because then I was moving it way too often. So a Dobsonian, you're moving it in this direction, you're moving it in this direction, and then in the eyepiece, there's also like the lateral movements, you know what I mean? So those movements are hard, especially when you have a group of people. If you go any higher than that, I felt like it was moving way too fast, and then by the time the next person came in view, it would probably be almost gone. So that's the only problem that I don't like of Dobsonians, is that if you're looking at yourself, it's probably okay-ish, but I like it from the low power to the medium power. Once you go beyond that, it's just the objects are moving way too fast. Now, if you're looking at deep sky objects, nebulas, galaxies, globular clusters and open clusters, those things you don't need usually high power, just a low to medium power. So then that's okay. But when I look at the planetary objects, the sun, moon, and planets, I want to push the power. 140 is not really close, okay-ish, but usually when I see the planets or want to see the planets, I like to take it up to like 175, 200, 225, 250. Sometimes I go up to 300. There's no way, if you don't have tracking or at least slow motion controls in polar line, you can't do that by hand every 10 seconds, you know what I mean? So this is why I love the equatorial mounted telescope, because even without a drive, keeping that object in the field of view is simple to do. Okay, let me take you to the chart inside. Okay guys, so here is another benefit of using an equatorial mount. And when you're pushing those powers, again, above 150, 175, 200, 225, 250, all the way up to 300 power. Now let's say here is your field of view. So what I do, like for instance, an altazimuth mount, regardless if it's tripod, a Dobsonian, or anything non-tracking type of thing, what you normally do is put the item, let's say Saturn, in the field of view, in the middle, because that's where your best view is. Most telescopes, if you have, I don't know, F4, F5, F6, the outer viewing might have, aberrations, coma, whatever it is. So your best view is there. So if you put it here, and depending what power you're on, let's say you're at like 200 to 250 power, you might have 10 seconds to go from here to the edge, which is not a lot of time. If you're observing with other people in the lineup, forget it. You're constantly moving. But here's what I like to do. Let's say, for instance, you put, what I like to do is Jupiter, Saturn, whatever. I could put it here. And then that way, I might have, at 250 power, maybe if that's 10 seconds, this is 20 seconds or something like that. It could be 15 seconds, maybe 30 seconds, depending what eyepiece field of view, apparent field of view you have and what power you're at. So what I do sometimes is put it here. And then that way, by the time it gets to maybe, over here, the vibrations dampen down. And I got a good 20 to 30 seconds to view. And then once it gets to over here, because it moves in an arc. Once your latitude is set and your polar aligned, semi-polar aligned, kind of polar aligned, or just roughly pointing magnetic north, it doesn't matter. It's going to be moving in one arc type of thing. So all you got to do is just, when it gets over here, you can get your control. You just 1/16 of a turn, put it back here. You got another 30 seconds of watch time. Now, really, what's also neat, one more thing. If you guys ever lose the object, normally you got to back it down. Put it again, 30 millimeter, 25, whatever the lowest power eyepiece you have to take out that high power, put the low power, find it, put it in the middle, and then keep bumping up the power. Now, what's good about it, if you're polar aligned and you lose the object, it most likely is going to be moving in that arc, right? So what you could do is, obviously which control it is and which movement if it is left or right, because you're following it for the last 20, 30 minutes. So you know. All you have to do is just turn that. Instead of 1/16 of a turn, you probably turn it halfway, a whole turn, whatever, but you'll almost guaranteed, okay, that object will come back into field of view. And I think 98% of the time you will see it, even if you lose it. Where the other way, with non-tracking, you've got to manually start all over and find it. So that's one thing that's neat about it. So try it out. If you haven't tried an equatorial mounted telescope or mount, give it a shot. I guarantee you guys might like it. It is a little bit more cumbersome because it has those angles and the latitude adjustment. And then, yes, it could be sometimes these, it seems like an awkward movements, but after a few times you get used to it. But it does have its benefits of, or even you put the object out of here, out of the field of view a little bit. By the time it comes into the field of view, the vibrations are gone, and then you got a nice long view. And again, if you ever lose it, you just twist that one control, and almost guaranteed you'll find it again. You don't have to back down the power. So then it's easy when you have a lineup of people. All you have to do is just tell them to turn this one to the left, a millimeter at a time, and there you go. So again, hopefully you guys find this information useful. Sorry that this is a repeat video, but I accidentally deleted it, so which means I lost all those comments and views. But I think this is going to be good for new people that are coming into the hobby. Well, then sometimes they hear it's only for astrophotography, or it's awkward to view at these angles, or maybe it's just a lot more complex to learn, which is a little bit true on those things, but it's mostly not. Once you learn how to use it properly. Anyway, guys, like, comment, subscribe. If you're on the forums and you see a video like this that's going to help out new people, or somebody's asking for it, please share the link. Why not you? Why not me?